Black holes are one of the universe's greatest mysteries. Imagine a vacuum cleaner in space that sucks in everything, even light. This makes them invisible to our eyes. Yet, they wield a powerful influence over nearby stars and galaxies. Black holes are like cosmic whirlpools, pulling in any object that comes too close. But they are more than just cosmic vacuum cleaners. They are portals into the unknown. Some stars we see may have already died, leaving behind black holes. These celestial objects defy our understanding of physics. Scientists use telescopes and complex mathematics to study them. The more we learn, the more questions arise. What exactly happens inside a black hole? Can anything escape their grasp? They are born from the remnants of massive stars. As these stars reach the end of their lives, they undergo dramatic transformations. Black holes begin their lives as massive stars. These are stars much larger than our sun. As they burn through their fuel, they reach a critical point. At the end of their life cycle, the star's core collapses. This happens when the nuclear fuel, like hydrogen and helium, is exhausted. Without this fuel, the star can't support its weight. The core collapses under its own gravity, compressing into a tiny point. This process is like a giant balloon suddenly deflating. Similarly, the star shrinks rapidly, forming an incredibly dense object. This dense object can create a black hole. The outer layers of the star may explode in a supernova. The heart of the star, however, continues to collapse. Eventually, the core becomes so dense that nothing can escape its gravity, not even light. Only stars with a mass approximately 3 times that of the sun can end up as black holes. 2 defining features make black holes unique. The first is the event horizon. This is the point of no return surrounding a black hole. Once an object crosses this boundary, escape is impossible. Think of it as a cosmic boundary line. It's like the edge of a waterfall. Once you're over, there's no going back. The event horizon is not a physical surface but an invisible boundary. Inside the event horizon lies the singularity. This is the black hole's core. It's a single point where gravity is unimaginably strong. All the black hole's mass is concentrated here. The laws of physics as we know them break down at the singularity. It is a place of infinite density and zero volume. Scientists are still trying to understand what happens at this point. Black holes can vary in size. Despite their size, black holes have a tremendous gravitational pull. When objects fall into a black hole, a strange thing happens. They undergo a process called spaghettification. The gravitational pull stretches objects into long, thin shapes. Imagine stretching a piece of dough until it's a thin strip of spaghetti. That's what happens to objects as they near a black hole's event horizon. The gravitational force is much stronger at the feet than at the head, stretching the object. This process is due to the black hole's intense gravity. It pulls more strongly on the side of the object closer to the black hole. As a result, the object is stretched vertically and compressed horizontally. For an observer, this process would seem to slow down near the event horizon. Time appears to stand still. But for the object, the process happens rapidly and is irreversible. Astronomers have observed stars being torn apart this way. The remains of these stars form an accretion disk around the black hole. This provides indirect evidence of black holes. Black holes are often thought of as eternal, but they aren't. Stephen Hawking proposed a fascinating theory about their end. He suggested that black holes can emit radiation. This is known as Hawking radiation. Over time, this radiation causes black holes to lose mass. Imagine a slowly leaking balloon. The air gradually escapes until the balloon deflates completely. Similarly, Hawking radiation slowly shrinks a black hole. This radiation occurs due to quantum effects near the event horizon. Particles and antiparticles are created in pairs. One falls into the black hole while the other escapes. The escaped particle becomes radiation. Over billions of years, this process can cause the black hole to evaporate. The smaller the black hole, the faster it loses mass. Eventually, the black hole could disappear entirely. Hawking radiation has not yet been observed directly, but it remains a crucial concept in theoretical physics. The life cycle of a black hole is a journey through extremes. It begins with the death of a massive star. As the star's core collapses, a black hole is born. The event horizon and singularity define its unique characteristics. They create boundaries and centers of immense gravity. Objects falling into a black hole experience spaghettification. They are stretched and torn apart, adding to the black hole's mass. Over time, black holes can shrink due to Hawking radiation. This radiation slowly diminishes their mass. Eventually they may evaporate completely. The entire cycle can span billions of years. Black holes challenge our understanding of reality. From their mysterious birth to their eventual demise, they captivate and inspire. As science progresses, we may uncover more secrets of these cosmic giants.